Alright, so in this video I want to show you just an easy way to memorize the unit circle. And math is not primarily about memorizing things, but there are some things that are so basic that you definitely want to have them memorized, and this is one of them. Okay, so kind of four things that we need. So this is just to give you an idea before we start filling this in. The unit circle basically refers to the following. It refers to the fact that if you were to draw a coordinate axis and put a circle on it, and then go like this. Let's say I kind of drew a triangle that looks like this. Here's a point which we'll call, we don't know what it is, so we'll call it x comma y. Here's an angle right here, and since this is a right triangle, we can use this acronym that we have, which is SOHCAHTOA, and we can express coordinates on this axis using SOHCAHTOA. So let's think about this. This side right here, this length, this blue length, is going from 0, 0 to, it looks like x0, and I know that this is x because it has the same horizontal distance as that point right there. That tells me this length is x, and by the same reasoning that length right there is y. And because it's a unit circle, unit means that the circle has a radius of 1. So this right here, this yellow line right here, is not only the radius of that circle because it's going from the center to the edge, it's also the hypotenuse of the triangle. So if we use SOHCAHTOA, we can think of it this way. The sine of this angle, the sine of angle theta, which is right here, is opposite, which is y, over hypotenuse, which is 1. But y over 1 is the same thing as y. So that means the sine of that angle is the same as the y coordinate on the unit circle. Okay, same reason, the cosine of theta is adjacent over hypotenuse, which is x over 1. So that's the idea of the unit circle. Any point on this graph, the cosine is the x-coordinate, the sine is the y-coordinate. Okay, there are four things that you need, and they're not, it sounds like a lot, but there's really not. There's four things that you need to be able to fill in this entire circle, which right now is blank. Okay, the first thing is you have to know these three angles, the sine and the cosine of these three angles, which are 30, 45, and 60. Those are the three most commonly used and probably the three most important angles in trigonometry. And here's a very easy way to remember it. First of all, everything is over the number 2. So all of these values are going to be something over 2. The sines count up, and I'll tell you what that means in just a sec. The cosines count down. So they're all, so the sines count up. So it's square root 1 over 2, square root 2 over 2, square root 3 over 2, and the cosines count down. Square root 3, square root 2, square root 1. Okay, but we don't really need to write square root of 1 because the square root of 1 just equals 1, so we could just replace that with 1. Okay, that's really all you need to remember when it says memorize the 30, 45, 60. If you know that table, if you know that the sines count up, 1, root 2, root 3, cosines count down, root 3, root 2, root 1, if you know that table, you can now fill in that entire circle that you see right there that's completely blank. Okay. There's two other concepts that you need to be familiar with besides that table. Number one, we'll skip 2 for a second. This right here, ASTC, stands for this. It stands for all students take calculus. And what that means is that on the unit circle, if we go by quadrants, this right here, this kind of line that I'm drawing, this is the green quadrant. That is the all quadrant. That means every function, sine and cosine and tangent, are all positive in that quadrant. All, and then the next one is students. The S stands for sine. So in this quadrant, sine is positive. All students take calculus. The take for T is down here. T stands for tangent. Tangent is positive right there. And you'll see why momentarily. So all students take, and then this last one is calculus. Cosine is positive here. Okay, so all students take calculus just means that in those quadrants that you see me label right there, each function is positive in those respective places. Okay, the last thing, we want to know how to convert degrees to radians, and we'll get to that when we start filling this in. And then the last concept is reference angles, and we'll explain this as we're going along. Okay, so the first thing we want to do is let's fill in these tables. I don't know if you can see, it's a little bit blurry. But each of these has kind of a degree, a place for degrees, and then a place for radians. Okay, this one here is 0 degrees. And then if we were to go a full circle all the way around, it would also be 360 degrees. Okay, then I said that these are the three most important angles. So in every quadrant, we're going to cover these. So this is the 30-degree angle right here. This right here is the reference angle of 30 degrees. That means when we find this angle right here, this is 30, this is 30, Here's the 30-degree angle in the fourth quadrant. Here's the 30-degree angle, sorry, in the third. That was the third, and this is the fourth. So let's find each of these. So this first one is 30. What's this purple one that has a reference angle of 30 in the second quadrant? And the answer is it's this angle right here, which is almost 180 except for that last 30. So that angle right there is 180 minus the 30. Okay, that's how we would find that. All right, let's use the same reasoning for that third quadrant angle, and actually I'll use a different color. So again, this angle up here is going to be 150. How do we know that? Because all four of those purple angles all are going to involve the 30 degrees. They all have a reference angle of 30. Okay, next question is how about this yellow angle? So this one goes all the way around here, and then we have that extra 30. Well, that first part is 180, and then when we add that extra 30, that's going to give us 210 degrees. So that's 210, and then the last one is going to be this orange one, which goes, there's 90, 180, there's 270. That's almost all the way around to 360, except for that last 30. So that means 360 minus 30 will give us 330 degrees. Okay, so I'm going to show you how to fill in those coordinates now, because now we know where those angles came from. They all have a reference angle of 30, and the angles are 30, 150, 210, 330. How do we now find these points? And that's why I said really all you need to know is this table. If you look at this table, we know that the sine, so the cosine stands for the x coordinate. That's what we said on this unit circle. Cosine was x, sine is y. So the cosine is the x, the sine is the y. So let's go to 30. The x coordinate goes right here, and the x coordinate, or the cosine, is radical 3 over 2. So that's going to be radical 3 over 2. And the y coordinate right there is 1 over 2, because the sine of 30, or the y of 30, is 1 over 2. If you know the sine and the cosine of 30, which I just wrote there, then you also know those other four angles that I wrote, 150, 210, and 330. Here's how you know. Okay, this right here, this 150 that has a reference angle of 30, this cosine and this sine will be the exact same numbers. So it's going to be radical 3 over 2 and 1 over 2. But the only difference is in this quadrant, only sine is positive. And if you look at this, remember that x stands for cosine and y stands for sine. Only the sine is positive. That means the x will be negative. Okay, the x will be negative because why? We're in the second quadrant. If you look at this axis right here, this is the point 0, 0. In this quadrant right here, what kind of numbers are x in the second quadrant? And you can see if x equals 0 right here, then as I go this way, the x's are negative. That makes sense. Then that would be a negative angle. Okay, that's exactly what all students take calculus means. It means in that quadrant, sine is negative. Okay, so I'm just going to erase this because this will start to get a little bit crowded as we fill it in. But again, we have those same exact numbers, negative radical 3 and 1 over 2. Let's fill in the third quadrant. So this angle down here is also a reference angle of 30. That means it's going to have these same two numbers, radical 3 over 2 and 1 over 2. Notice that in this quadrant only tangent is positive, so that means both the cosine and the sine are negative. And then finally over here, this is another angle of 30. It's still going to have these same two numbers, rad 3 over 2 and 1 over 2. In this quadrant, only cosine, only the x is positive. That means the sine is negative. So we're done. We filled out all of the 30-degree angles in all quadrants. Okay, next one we want to do is 45, and hopefully you can probably see how the reasoning is going to go. Okay, so 45. So this 45 angle is going to be right here. We took care of the 30-degree one. That's going to be 45. That means this one here will be 45. The reference angle, that is. This one here. I'm going to this second line, by the way. You can probably see how there's three lines in all of them. The middle one is the 45 because that's in between 30 and 60. So this angle here is 45, and that means this angle right here is also 45. So in the first quadrant, 45 is just 45 degrees. In the second quadrant, we're going to find this yellow angle right here by doing 180, because that yellow is about on its way to 180 except for that last 45. So this number that I wrote, 135, is 180 minus 45. Let me erase this for a sec. Okay, how about the third quadrant angle? The third quadrant is going to be 180 plus 45 plus that extra 45. Okay, oops, and that's going to be 225 degrees. And then finally this last angle, just clearing this off as we go so we have more space. This last angle right here is going to be, let's see if I can get this to work. This is going to be almost all the way out around, almost 360 minus that last 45, and that's 315 degrees. So we now have our 4 angles, and once again we're going to use this table. Okay, this time we're going to use this 45 right here. So every answer on this table is going to be something with radical 2 over 2, because both the sine and the cosine, remember this is a 45-90 triangle. That means the x coordinate or the cosine is that, the y coordinate or the sine is that. Same thing over here, the x coordinate is this, the y coordinate is this. However, in this case only sine is positive. Sine is the y coordinate, so that means the x will be negative right there. The x is cosine, and cosine is not positive. The x is not positive in the second quadrant. Down here we're going to have radical 2 over 2 for both again, but in this quadrant only tangent is positive, so that means both sine and cosine are negative. And then finally in the 315, it's still radical 2 over 2, because this still has a reference angle 45, but only cosine is positive. Cosine is the x, and sine, sorry, that's supposed to be a negative right there. Sine is the y, so sine is negative. Alright, last one, and then we'll also get the quadrant angles, and those are actually the easiest ones to do. So kind of running out of colors here. Let's see what we can do. So the last angle right here is this one. That's the 60-degree angle, so that's this part right here. This angle right here is the reference angle of 60 in the second quadrant. This is the reference angle of 60 in the third. This is the reference angle of 60 in the fourth. So that means this angle is 60. The second quadrant angle is 180 minus 60, which is 120. Third quadrant angle is 180 plus that 60, which is 240. And the fourth quadrant angle is 360 except for that last 60, or 360 minus 60, which is 300. So let's clear all this stuff off, and then what are we going to fill in? Remember, the cosine is the x coordinate. So the cosine is right here. The cosine of 60 is 1/2, so that means every one of these I'm going to put a 1/2 for all of the angles. And all I need to do is go back and say, well, in this quadrant all things are positive, including cosine. In this quadrant sine is positive, which means the cosine is negative. In this third quadrant cosine is negative because only tan is positive. In this fourth quadrant cosine is positive, so I'll leave the 1/2 alone. Okay, then the next one we need to do is the sines, and the sine of 60 is rad 3 over 2. So radical 3 over 2, and that's positive because all is positive. Radical 3 over 2 here, and that's positive because sine is the y and sine is positive there. Right here it's rad 3 over 2, and that's negative because tangent is the only thing positive there, and we're dealing with sine. And then finally radical 3 over 2, and that's negative because here only cosine is positive. So we're almost done. Last thing we want to do is fill in the quadrant angles. This is a unit circle, and the unit circle has a radius of 1. So that means this distance, all the way to the edges. I'm not going to draw it in because we'll cover that up, but these are all distances of 1. So we will keep that in mind as we fill this chart in right here. Okay, so this coordinate right here, if this is a distance of 1, that means x is 1, because that distance right there is 1. And we haven't gone up or down, so the y is 0. Over here, that's the same distance, but it's in the negative direction, so x is negative 1, and the y is 0. Up here, we went up 1, so y is 1, but we haven't moved left or right, so that's 0 for x. And if we go down, x is 0, but y now down here is negative 1. Okay, so let me erase this stuff so we can see these unit circles tend to get pretty crowded. And then finally, all we need to do is get the angles. So this angle right here, we already said is 0. This one is 90 degrees, because that's a right angle right there. If you go all the way over here, that's half a circle, so that's 180. If you go 3/4 of the circle, that's 270. And if you go all the way around, that's 360, and we already took care of that before. The very last thing we're going to do is change things to radians, and that's that last blank space we have. So here's all you need to know for radians. We need to know that all the way around the circle is 360 degrees, but it's also 2 pi radians, because 2 pi r is the circumference of the circle. So 360 degrees equals 2 pi radians, or if we were to divide both of those by 2, we would get 180 degrees is pi radians. So 180 is pi, so let's fill that in. Okay, so we have, that means this is 180, that's pi. Since 90 is half of 180, that means it's half of pi, or it's pi over 2. Okay, so you can think of it this way. This is 1/2 pi, this is 2/2 pi, or just pi. This is 3/2 pi, or 3 pi over 2. And this right here is 4/2 pi, or 2 pi, because 4/2, if you reduce that, it's the same as 2 pi. Okay, that's also 0 in terms of radians. So that's the unit circle. That's how you fill it in. Hopefully it makes a certain amount of sense. It does take some getting used to, but it's definitely useful to know when you're doing trig.